Welcome everyone to another week on the Creators University. Please don't adjust your set. The headwear is appropriate to the session because today we'll be going to discussing architecture. I couldn't resist. I'm nuts. It's official. Anyway, as we're getting on, so quick recap through what the streaming schedules. We've got it is Halloween, so maybe so. Around what MonoGame is doing and getting out there, so you'll know what's out and about and tune into what's over there. A quick overview of where we are and where we're going, and then we're hitting straight into the course. Now, it's been a quite light news week this week, so there's not too much other news to recap, so we can actually delve straight into the actual tutorial itself. MonoGame itself is we're actively out there on the stream, so we have our open hours every month, which showcases what these latest status updates from the foundation are. Usually a result of one of our board meeting the week earlier, making sure the fact that things are progressing and moving along as we would like. Tommy's coding live every Friday, and with little pop-up sessions like we had on Tuesday, where we're going through the whole new content project system. Keep an eye out for all the short and quick tips for getting to use that. We're getting ready for 3.8.5. MonoGame University, obviously today, and obviously then we're still asking if there's anyone else any other streams or what kind of tickles your fancy and what should be out there. So obviously the main two streams we've got at the moment is the university, which are out today, with or without hats, we shall see, and Tom's coding on Friday, so stay tuned. But anyway, one thing we'll still keep leading off for a while because it is a fantastic announcement, is that there is an actual MonoGame book out there now. There are actually a few, but this is the latest and greatest from Langille. We do highly recommend you check it out. It's a good introduction to MonoGame, as is a lot of the MonoGame content we're doing now. But they cover different things in different ways. And it's always good to have more than one source to check your facts and see how you're going. And let's get on. Now, see, there's a main. Someone has pinged. There we go. I thought it was going to be a repeat of Tuesday. But no, thankfully. Sorry, Betsy. Yes, we're going all pirate because we're doing architecture. I had to check that wasn't muted. We had an embarrassing thing on one of the last streams where we stayed muted. So yeah, there we go. I don't know how long this is. This itches like anything. But anyway, short, sharp, sweet. Getting in, getting on, and doing what we can. So what we say, like I said at the start of the screen, if you can, give us a like and subscribe if you're following us on MonoGame, and if you're on Twitch, then hit that bell and give us a follow. That way you'll get up-to-date notification when we're going live and what the schedules are and what's going on. But also follow on the MonoGame Discord, and we'll give you the latest updates of when we are, what we're doing, what we're changing, and then as much notice as we can. But anyway, if we dig in on, moving ahead, obviously here we're talking about MonoGame. We're going through the 2D tutorial. We've had a slight revamp in the site recently, mainly just to try and control the flow, how you get access to information, especially for new starters. So obviously you have the big getting started button, as well as all the news that's down here. And this takes us now, you can see now, first and foremost, this very same 2D tutorial that we're going through is now front and center. You can then still delve into all the documentation and all the API, a few how-to guides which tell you how to do things or what things are, a good place to look out. The selection about all the tutorials, which there's a few in there, but obviously we're building and working on more, the samples, and obviously the roadmap for where MonoGame's going. And obviously, if you're clicking through it here, takes us to today, where we're up to chapter 4. So before we delve into that, so something to highlight now is that keep an eye on YouTube, because we keep trying to put out all the short form content. So from the content builder project stream we did earlier in the week, we're pumping out sort of smaller bite-sized chunks. So if you need to delve into what the content pipeline is, we've just recently put up a short about that. There'll be another one about the actual new content project system, as well as a little short snappy how to actually get it using in your project once 3.8.5 drops, or if you're really feeling adventurous, you can do the 3.8.5 templates that are there now, which is the develop release, the very early access top of the line if you want to take out the latest and greatest before it's even official. But we're really excited. We're trying to ramp up pace now to close down those last few issues, because even though the content pipeline projects, the Vulkan and the DX12 are still going to be classed as preview, so not production ready, they're preview, we still want to make them the best we can. So that then when you're out there testing these things and doing them, you're making the best out of it. And also the feedback we're getting is more like what we need. But we hardly suggest all your existing projects are going to work exactly on. Nothing is changed from 3.4.1 now for your core projects. So everything's stable and released. We have these new features to take advantage and play with at your leisure. But anyway, back to today. So class libraries. Effectively, we're talking now about game architecture. I'll see how many times we can get that in. Where we are effectively talking about how you structure your project. So if you do a .NET New and just want to use one of the MonoGame project types, you're going to get a self-contained game. It works on one platform, all the content's embedded, and it's just a single-use thing, which is fine. That will work. It's great for little indie game jams and going off what you're doing. When you're starting to plan for doing your more larger scale project or even planning for your multi-projects, you're going to do many projects over time. What you'll find is that a lot of the code you write, you want to use again in another project. You don't want to have to rewrite it all again. And worse, if you actually take a bit of code and you actually make improvements and you want that improvement to be available in multiple projects, just copying and pasting it, it's not going to work because you're going to forget where you are, what you're doing, how you're going. So this is where things like class libraries come in very, very useful. Effectively, what they are is a self-packaged component, and they just contain code or content in some cases as well, but effectively shared stuff. And instead of having to copy and paste or link files and things like that, you simply attach a reference to it, and then that's your code. In essence, that is what MonoGame is. MonoGame itself is just a library that your game connects to, and it's getting all the code from MonoGame. And then anything we change in MonoGame, you can get free in your project. You can do the same for yourself. And there's nothing to say just to have one, although generally speaking, it's until you get used to it and how you're building code and how you're creating your projects, you want to keep with one. And then as and later on, you think, well, this is my animation system and this is more useful on its own, or this is my input component and this one to do here. And you might componentize further, not just one library, but several. So as Chris has shown in diagrams here, so we've got game 1, game 2, all the same systems, all the same code, but you're rewriting it several times because you put in the same project. Where if we move these things into a class library, both games are using the same code from the same place, it have the same updates. So as you update one game, you get the improvements of what you've done in the other, as you improve the things. Granted, it's not a free pass, you still have to test. So while you might be changing code in your library, it's about outside the scope of where we are now, but we have what's basically called unit tests. So you test code that's in these libraries to ensure that it always does exactly what you expect. So you always get with the same expected inputs, you get the same expected outputs always, or else things will break. But even so, that's still, it's a case of, as you're having multiple projects using it, you still test to make sure that your project still works the way you expect it to. It should. It's your code. You wrote it. There's only one person to get blame in a project of one. But as you expand teams, or if you use multiple developers, it's good to know a case of where code's coming from, who's maintaining it, and how your project's using it. But using a class library means that you've got a shared bit of code that's always being used, and you don't have to worry about maintaining it other than keeping up to date. But it also means that, and this is where it comes critical, especially in projects like this, it's separate. So if I've got an Android build and a desktop GL build and an iOS build, I don't want to have different code and different game library code content for different things. 90% of the game is all the same game. I only want to write it once. So each of those projects is simply going to go game run and call the class library and get the code and run your game. It just makes good sense. And so effectively, class libraries give you reusability, they give you better organization of code, and also like maintainability and testing. Those that are very well steeped in how they build the code, like I say, will go more into the testability side. So we write tests to test code, as I said, and you make sure the case of in advance, as early as possible if you're going to make a change or trying to alter how something's going to work, it's not going to break everything else that uses it. Or if it does, in advance, so you then need to know, right, well, I've changed this to work better. I now need to go back into the other projects. It tells me in advance, you need to go fix this. The signatures change or the updates change or how it's working has changed. You get the idea. Adding a class library in a project, we'll come to this in a minute. Very simple. Chris is quite rightly as well also given examples here for both Visual Studio Code, for Visual Studio, or even just doing it from the command line. All these options are available to whichever way you cut your cheese and want to be able to go and build your project. Once you've created a class library, like MonoGame, you then need to create a reference to it. So your game project, running as it is, needs to know that that code exists. So you just simply create a reference link. Again, instructions in all three. We'll go through this in a minute. Then how to link your game project to this class library so it knows the code exists. Now, once that happens as well, the thing you need to watch out for is collisions. So if you have the same class within the same namespace in both projects, they will collide and give you errors. So if you're suddenly wondering why adding this library suddenly breaks things, it probably means you're either halfway through, you've done something silly, and you've got the same code in both places. Code can only exist with the same format and the same signature in one place. And this is where cleanup. We'll go through this, and then we'll create a module. Now, if we switch over to the actual project itself, this is where we left off. Now, I have to hold my hands up. I made a major faux pas. Now, when we started this course, one of the things we tried to highlight or tried to showcase was about using proper source control in your project. If you make changes, you save those changes, and then you commit them and then push them up to a backend server. So anything happens to your machine in between you opening up, who's there has been there when they've gone to turn the machine on, and all they've been left with is either black smoke or a blank screen. You never want your code to be existing on the machine that's just suddenly died. So as a good practice, you should always, if we go into the source control tab here, commit any changes. Now, granted, it's not a hard rule, but a rule I usually follow in case of generally only checking working code. And we hit an issue in the last project, and I have had Chris ringing my ear because he's just screaming at the screen, that if I hit play right now, in the way that I build it, so I build a project by creating a project, splitting it up manually, editing the solution file is one way to do it. Chris explains another in the tutorial where you actually use Visual Studio Code to create your project for you, and it's already in that format. But because the way I break it, this doesn't run. It doesn't do anything. And the reason for this is down here. So while, yes, I've opened the correct solution, which is one option, the debugging mode of how I'm actually working with this project is wrong. Because the moment it's trying to run it as a C# project, where realistically, I need you to change to a C# and actually load up the actual project I want to run. Simple newbie error. I clicked on the wrong thing when I did it. And you have two realistic options. You can either select the project you're going to start, especially if you've got a multi-project solution, or you're just launching the default startup project, which is defined by your solution. Best way is to simply click on the actual project itself. That way you know you're calling this project, it's running, and you'll see now I'm running, and it's like, well, it's over here. I don't know why it's doing this now. And there is my project running. So I'm now running from here. So my project's running. I should have, at the end of the last project solution, checked in all my changes. So I simply select add to stage, which means these are the changes that I'm going to have ready. And if you stage changes and then make further changes, they will appear down here because there's a difference between what I said I was going to commit and what the current state of files are. So ultimately, when you're going to commit only those items you've staged or you've got ready for check-in, is what you want to check in, and then here we're going to reorganize project. As a good tip, and I've said this before in other streams, your commit messages should be something you know what they mean and also make sense. So especially if you're working in several people on the project, you are both understanding what changes are. Oh, my screen's up. Oh, I apologize. Let me take that ticker off for a second and just show that again. Nope, not that one. Oh, there we go. Right. Thank you, chat, for pointing that out. So I'll quickly go over that again. So whenever you're at your project, you're having issues doing build and run within Visual Studio and it's not running, you need to both check that your solution file has been set to what is the actual solution there in your project, and that your project that you're debugging here is also the project that you want to start. So in this case, it's it's this Dungeon Slime CS project. So solution and project. Thank you, Mutsi, for pointing that out. Although I need to put that on because then no one knows what I'm talking about. Let's see about moving that up in the future. But anyway, so that's my commit message. I've staged the things I've done. I'm going to commit it. Now, committing puts it on your local machine. I've saved it here, still a copy, but it's still on my machine. If I wanted to put it in the cloud server to make sure it's in the repository, I can then synchronize or push those changes up. And there, my local machine now is in sync with my cloud. If anything happens to my machine tomorrow or today, then I can go to any other machine, I can clone down that code, and I've got the same working project. I don't lose any work. Believe you me, when I was authoring one of my books, I lost an entire chapter. After that, I was committing code in, I had synchronized changes, I had cloud backups, the works. Having testable changes there, so I can see here now, if I look on these things, if I click on each commit message, it tells me what I've changed. So in there, I updated this. If I close there, you can see I've updated that. I've edited this line, and can shows you what's changed. Anyway, that's an aside and a catch up. We're back to where we are now. We can go here. So here we are. Well, we've got our one project and our one solution. All's working nice and well. Oh, here we go. Spam. Thank you, Cactic. We're going for a different hat a week. No one's noticed yet. This is the first week people will notice. I will likely not wear this when I get this because this is itchy. What we're doing, architecture. That's my poor imitation. Anyway, okay. So as we talked about with the tutorial now, we want to add a class library to this project. It's very simple, very easy. And you have the Solution Explorer tab down here in Visual Studio Code. If this doesn't exist, or you can't see that, the simple reason for that is that you need to ensure, we'll go back to the tutorial, where are we there? And you need to ensure, Chris points this out now, that you have got the, where is it? Basically the dev extensions. I've lost it. There it is. I am blind. So if the Solution Explorer tab's not showing up, you need to make sure you got the C# dev extension. Let's make that bigger. No, that's going smaller. Going the wrong way. Be sure they got the C# dev extension installed and running, and that way your project has got everything it needs. So in the Solution Explorer, adding another project to this. Now, if anyone's just watched the shorts about, or the last stream about the content project, you'll see it's here. And MonoGame has its own pre-built-in class library. Now, where this helps you means that it's a class library, not just as a C# just library. It also has all the actual MonoGame references in it for you. And there it is. The MonoGame game library, and let's see, so we call this now. We've given this a specific name, the tutorial. Let's keep going with how it calls it, and we'll call it the. There we go. Oh, I'm going to do that again. Class library. I'm going to call it the MonoGame library. Very aptly named. And you'll get asked where you want to put it. Keep it as default, just means it's in the solution, and it's going to create the project. Ta-da! No, I'm going to make this bigger. So here we have now, we've both got our game project with our game CS, and we've also got, let's make this bigger. There we go. And we've also got our MonoGame library, which comes with its own game class, and also it also comes with content. Now, we're not going to use content in this project, so we're going to remove that from there. And we're also even going to remove this game on CS because we're going to create our own, nice and fresh. But you can see here now, if I look in here, it's got the MonoGame packages, and it's also using all the proper references. It's all set up for MonoGame essentially. So there's our second project in there. And if I go back to my file view, I shall see now that I've got both Dungeon Slime and the MonoGame library. If I check in my source control, go on, can I collapse that? Yep. You can now see that changes include, I've got updates to the solution, it's added another project, it's added small chunk. It's also added the actual project reference and also other things with it. Anyway, now that we've got our library, we can actually start to put things in here. So we're going to create a new class file. What we're going to do is called core.cs. We'll explain and walk through this a bit more. No, I just want to, no, I don't want to do it yet. Right, so in the library, I'm going to add a file. I'm going to call it, I'm going to collapse the window. I'm going to Control V and B are very close together. There we go, core.cs. Nothing in here in the moment, and I'm literally going to copy Chris's code, and then we can talk through what this is doing. Because what this introduces several of the key concepts as well. So most code in MonoGame, well, or in any game really, or C# project, is just an abstract, an instance of a class that you're going to use. To use it, you have to create a new one. You create an instance of it, and then that's in there. But if I'm going to use the same class in code in multiple different places, which we will do in this game, then you don't have to keep creating the same one over and over again. You can either have a reference somewhere to keep calling to, which means you need to have reference to the reference to a reference to actually find it. But what we have in programming and also in game domains, we have what's called the Singleton pattern. We have a reference to this here. So we look here. And what the Singleton pattern basically says is that I'm going to create a static, or basically a piece of code that's only ever going to be one instance of this in my entire game. So every time I call this, and if I look up the class, it's going to call back the same single thing. We have the reason we call this a Singleton pattern is that we have a static class, so there's only ever one of them, but we make sure there's also only one way to access it, and also we're also using the most common or latest instance of that as we're calling it. So every time I call it, it's the same thing in the same place, in the same way, with all the same state. It's a tricky pattern to use at times, and it takes a bit of practice. One thing you don't want to do is have this everywhere, because it looks like a magic bullet for solving so many problems. It's like, oh, I've got my game state, it's over here. I can put a static class over here. I've got all this other stuff. Oh, I can have a static class there. But therein lies a danger, and it's one of these things where with great power comes great responsibility. Yes, there was only one. That can only ever be one. If you suddenly try to create multiple of these things, it goes very badly for you, because they start overwriting each other. The reference, the area where they reference in memory can get corrupt. So the general best advice is you use these sparingly. It is a powerful tool, but try to limit your use of them unless you really know exactly what you're doing. But here, we've created this. So it's a normal class. So it's not a static class itself, but we have a static instance. And this is where the Singleton pattern comes in. So I've got my core class, but it has a single static instance. So if I need to look at this core class, I can get the one and only copy of this that exists in the entire runtime of my game. Any changes I make, any updates I do, the state of things are all stored in here in this one instance. So for instance, where the tutorial uses this is that we create a single instance version of the graphics device manager, which normally is just in your base game class. We create a single instance of the graphics device, very useful when we start drawing and throwing to the screen. We have a single instance of the sprite batch. Now, this is one of those things where it gives the freedom of, this is like a global sprite batch, and you might have a different version for different things as well. This tutorial keeps things simple, and you're going to use one throughout the entire game when we're drawing. In all the tutorials, things like the shader tutorial and things like that, we actually might use several different types of sprite batches for different things that we're going to do, or in different ways that we're going to draw. Again, it comes down to experience and trying things and see how they work. But also, more importantly, we have one instance of the content manager. Now, with content, you can have more than one content project. So I could have a project which has all my large-scale assets. I could have all my content for a specific level and then unload that level and just load the next one, or having different ones there. Now, although management that can get a bit tricky. So we generally say use one, and then if you're finding that you're having memory issues, or if you're having problems trying to keep the game running at a certain level and you need to start unloading content, you can have more than one. One good practice, which we don't go into here, is that you have one central content management, which is for all of your core art and assets. These are things you're going to use everywhere in your game. And then for each level, you'll also have a level specific one, which just contains art for that asset. Or in some instances, like say a different biomes, you might have like a wintry biome or a summer biome. And the only thing that's different between those two is that the same types of content, they just look different. So you put one in one content manager, one in another. It means you can just unload all of one biome and then thread it into another. Hi, Nitro. Love to see you on the stream. Welcome on board. And yes, I don't like download. To my sins, Nitro. Yes, I have to use Unity. Unfortunately, my day job, not just my MonoGame work. If I didn't have to use Unity, I would much rather be building in MonoGame. It gives me so much freedom, and also it doesn't tell me what to do. I don't want to have to tweak this transform with a local transform and put this transform over here just so I can get an animation to work the way I want it, and then have it disappear because parenting. Anyway, back to the zen of MonoGame. So we then have a constructor for this class where the very first time we install this, we create it, and then we ensure that there's a single instance of everything we're doing here. So there's only one instance of this graphics device manager. We've got one setup of all the things. If I try to create another one, it's going to warn me and say, whoa, no, you already have one. The reason this is important, we'll come back to later, and you'll see through this entire tutorial about how this becomes useful. But again, tempered with wisdom of use it sparingly. So we can sit here, you can set up all the things. We're even using them. I don't know why the mouse is on by default, but we'll go with it. Then you can see, because this class also inherits from game, so this is also a game framework. This also then can inherit from the MonoGame framework methods themselves. So when the game framework initializes, it's going to ensure the fact that the graphics device is set up, and it's also going to ensure that the sprite batch is created. All well and good. That's our core class. So that's created. If we hop back over to where our tutorial is going through, and yeah. So we've got our first library module. It's there created, and it's got a nice class. But obviously, at the moment, our game isn't using it, and we still need to then start. So if I run my game now, it's just running the game as it always was. There's no shared code. It's just using what it's got. So in order to then make our game recognize this library and use it, we have to do a few things. So first and foremost, we can close that now, go back to here, is that at the moment, these are two completely separate projects. Dungeon Slime does not know about the MonoGame library. MonoGame library doesn't know about Dungeon Slime. Now, I am going to make a reference, but all references have to be one way. I can't stress this too much. Every project can depend on another, and then that project can then depend on other projects. But you can never get into a situation where you have this project depending on this one, and then this one depending on this one, because you then have a circular reference. That is very bad. It's basically an infinite loop. Your program won't compile or complain with lots of very strange errors, and not all really telling you exactly what's going wrong. But keep in mind, whenever you're creating references from projects, it's always one way. If there's ever an instance where you get into a situation where you got this project needs some code from this project, which needs some code from this project, but then needs to go back to here, your architecture needs to be redone. The code that if you get a certain thing, the code that's being dependent upon by another dependency, you'll need to move that somewhere else or create a different way of accessing it, because you cannot have circular references on projects. Thank you, John. We're here discussing architecture. We have just had Halloween. I'm allowed a bit of eccentricity. Anyway, creating references is very easy. We're going to go on the dependencies, and we're going to go, and we're going to, oh, why are we not right-clicking? No, okay, so right-clicking the project. And in this case, you've got several options. Now, if this was like a library off the internet where the content library owners like pushed it onto NuGet, I can create a NuGet reference. And that basically creates a sort of a silent connection between here and the package that's currently published, and then it will download it and reference it. In this case, we want a project reference because I want my Dungeon Slime project to reference my library project. Once you click this, it's going to say which project you want to reference. At the moment, we've only got one. If I had multiple, I could add others. And this is also true for like extension projects and things like that. If you have a content project that needs to reference an extension project, same thing. We create a project reference or a NuGet reference. And then we can see this here nicely. Let's get this bigger. No, I don't want to do that. I want to make this bigger. There we go. So we can see here now in the dependencies on Dungeon Slime, I've got a project reference to the game library, which is then down here. Good. Now my Dungeon Slime project knows that the library exists, so I can start to use its code. So it being there and good, I need to reference it, but I also then need to tell my code it's there. Because the moment if I look at my code here, so there's my game. Okay, so it's all there. If I start to try and say the core class now, so if I try and create an instance to it, right. So I've got my core class. It doesn't know what it is. Now, this is where you get tricked out sometimes when you're typing in. If you're copying from a tutorial and pasting into here, it won't autofill things. But when you're typing, it will. So it recognizes now, because Dungeon Slime knows about the MonoGame library, I can actually create a reference to that. And it goes, oh, by the way, you know this is from here. If I clicked on this, it will add in what we actually need at the moment. We're going to send it back out, which is this. It's called a using. A using reference simply says, right, if you need to go and find some code you don't recognize, try looking here. You see these already with MonoGame, where we're using the input library, we're using the framework and graphics. So that way, things like the graphics device manager, which if I hover over to here, you can see, this comes from the XNA framework graphics device manager. So that's being picked up from this using, and it knows what it is. If I took this out, apart from everything breaking, I can't see game, can't see graphics device manager. Same thing, because we're creating a library, it's the same way that MonoGame works. It's the same thing. We're creating a using. Go look at here for code, and then the compiler will know what to look at. Now, what we want to do here now, essentially, is that while, yes, our game's inheriting from game, it's fine. We might as well use this new core class because it's doing a lot of the work for us. It's going to provide all the capabilities and functionalities we need. So we want to change where we are inheriting from here to actually from the core class, not core. I'm going to turn off. No, I'll leave it alone. Okay. So now our game is inheriting from core. So all the code we've just copied in our library is now available and accessible within this game class, which means there's a ton of things we don't need to do anymore. We don't need to do these because they're handled in this core class, and they're also available in it. We do need to change how we initialize our project, because in the constructor for the core class, if we look at that quickly, there we are. in the constructor for the core class, we can see that it needs a title, a screen width, height, and full screen, so we can do all the setup for us. It means project to project it's the same. So we copy these over here. Nope. Do that. Let's copy properly. And the way we're initializing the constructor is that the code is not in here because it's not the game class that's been initialized. It's this. Where you see base, it means the code that I'm inheriting from, go and initialize that one rather than here. Now again, all this stuff again is already in here. All that happens here, so we can see graphics manager, setting the analysis is true. So because that's now been done for us, we don't need that here. Our code in this project is becoming much, much simpler and a lot easier to manage. And we can also get rid of this because the sprite batch is also initialized in our core project when it gets initialized. So we don't need to worry about that. And that's it. So now we're still doing update because the only thing we're doing in the core class is we're initializing things. We're preparing state and setting things. Now I could do other things in here. I could have it so that it's always drawing a certain graphic bouncing on the screen. And then everything that inherits from this would then get the same code. We're not going to do that because we're using this core class as a management library. It's doing functional things for us. It's capturing the state of things. So what screen is my game on? What graphics device is available for my drawing? Not that we're going to change in drawing. And also because the graphics device is initialized in this core class, not here, it means all this now will just work. So if we run this now, okay, we'll just double check that. If I run, obviously run will now work because we fixed it. I have to stop breaking things. Apparently, I've got Chris shouting at the screen every time I break something. And now, there we go. Our game's still running. Nothing's happening. We're not drawing anything yet. This is more about architecture of how you build a game. I find, especially as you're beginning to build games, having a good footing for how you structure your project is critical because it sets the foot for how you're then going to move forward. Having a simple project and simple thing, yes, it'll learn you to code, but it doesn't teach you how to actually build a project properly, how to deliver it out. For instance, so this is technically, if I collapse these down now, so in the solution here, I've got Dungeon Slam, which is actually technically the desktop GL project. That's where it is. I'm going to undo that because I don't like it. If I wanted to then go and add an iOS project, so I'll go and add another project. I'm going to say MonoGame. If I know it, let's be funky. Let's find a Windows project. Okay, so I'm going to call this done. Actually, technically call it Windows, but for the sake of argument, we're going to put it there. So I've now got a DirectX project. At the moment, again, that's on its own, but we'd have to go into here and do the same thing we do the other one because there are ways to even make this quicker. But if I go back to here, so if I copy off the bits that I changed here, I do this to here, you'll notice now if I cut and paste, it's going to go, what? No, I don't know what this is. Another handy tip, keyboard shortcuts. So control and full stop or period will go on. Oh, no, it won't. Aha, because this is actually a good example of the way we should have done before. So I've created this in the other project and I've tried to use code which is using this core class. But this DirectX project doesn't know the MonoGame library exists. So we have to go in, add a project reference, not the desktop shell, but we're going to use the MonoGame library. And now if I go over here and go that, it's going to go, yep, I know where that code's from. It's from the MonoGame library it's using. So down there, I'll go and go DirectX project. And if I wanted to, I can go and change this now. So see, I'm going to use the DirectX project. Is this all going to go horribly, horribly wrong? We don't know. We shall see. We'll find out. Oh, hello. And there we go. Hey, I unlocked DirectX game. Now, both games are using the same fundamental core code. And this is where the power of this comes in. The more I add now to this core project, both of those projects inherit from. Anything I do there, both the platforms get. So as your game evolves, the only thing realistically different between different platforms, apart from like screen resolution, things like that, how you compile the code, how you package it. Your game is still the same. You only want to write your game once, and once only, and so forth. But anyway, there we go. I've now created the multi-platform project. Now, that's only possible because we set up a good architecture from the beginning. I've got shared code. I've got my platform code. We can take this further and how that works. But ultimately, it's a case of you can see how setting this up, as Chris has alluded to in the actual tutorial, this is a good way to start. If you start good, later on it can only get easier and better. And we can add more things on it. If you want, you can go look at the content project stuff and jump in board and see how it's working. Aha. So, you know, I'm going to, those things will work. Let's just make sure. Does the desktop GL one still work? For some reason, it's still good. No, okay, it's not there because it's called something else now. It's called that one. There we go. Oh, there we go. Yep, my desktop GL one's still working. And the reason why this was complaining is if I look in here, no, I just want to look at my. Okay, so that's wrong. So I need to look at my. If you ever see things in here that you, so at the moment you see I've got desktop GL, DirectX, but it's also got this one, which is the old one. It doesn't clean up after itself. So if we go back in here to VS Code, go to here, go to view. Yeah, we see we got a launch JSON. We don't need that one. Why are you still calling that? Interesting. So you've got you. So yes. We got you. Now I'll delete you. Yep. You can delete those so hard to get down. It's not going to break anything. No, you don't need to worry. So now when we go back into here, that's not refreshed. It needs to reload. Anyway, next time I close Visual Studio Code and reopen it, it's going to have the same things in there. But anyway, if we go into here now, oh, look at that. Now, see, we're doing proper practice now. I've finished my day's work. I've got my new library. I've got all the code set up, and I want to move on, safe and sound for tomorrow. So I know that I've got in here, I've got, let's see, the solution. I've added 2 projects now. Good. So that's happy. I've renamed that one just for argument's sake. And then I've got a lot of other things. Yeah, we'll get rid of that. And there's all my changes. I've got stuff that's coming with the DirectX project. Yep, I think that's all fine. Yeah, that's fine. So there we go. At the end of the day, both my projects run. They're both using the library, both working. So, and we make a very good commit message. Created library, not Pete myself. Can't spell. As a platform, there you go. Commit it, push it up. Now, anyone who's looking at the actual GitHub repo for this, which no, I didn't have loaded ready. Let's go and have a look. MonoGame. Okay, not there. Let's see now. The interesting thing is, as you push things to GitHub or to your subsequent repository, GitHub especially, the last thing you pushed or changed is the one that's there. And there we go. You can clone this, you can play with it, and you can see there's my DirectX. I should really rename the folder to thing. I might do that offline because it's a bit more work and you have to update the solution file because it's looking in the folder. So that's looking Dungeon Slime. This one's looking in Dungeon Slime DirectX. I should rename that folder as well, but I need to tinker with that because it's not a friendly way of doing it. But anyway, have your questions ready then, because we are pretty much to the end of today's lesson. Let's see, is there anything else we need to cover in here? No, but we run the project. Yeah, if you get a bad namespace, you've not added the reference, and there's lots of questions and answers. Benefits using a game library, it just makes sense. Oh, that's not the answer. Done it. Use a template instead of a class library because you get the MonoGame references involved, or you can add them manually. Some people like to do it all themselves. You can do. I'm not going to stop you. What happens if you do not add a reference to your class library? It won't work. I like it because I love those Q&As. They're brilliant. We're going to try and keep these in other tutorials. So anyway, that's it for pretty much for today. And hopefully you get a lot out of what goes into good game architecture and how you can structure your project to make your own life easier as your game evolves. Whether or not you're going to target one platform or you're going to add more later, whether or not you're going to use the same code in multiple projects over time is a completely up to you. But having a good ground start and having everything ready so you can do it is always better to do at the beginning than when you're halfway through then realize you need to refactor and restructure your entire project because the client suddenly turned around and said, we're not on Steam or we're not on Linux, on the Steam Deck. Can you go and change it? And then you end up having to rebuild everything. Not happened. True story. So no questions in. So, okay. Follow and like and subscribe us on Twitch or YouTube. Always a good place. And if you can, obviously, we encourage people to try and sponsor MonoGame. It's what helps us to both do these streams and also all the advanced work we're putting through and accelerating the development of MonoGame, including adding new platforms, adding new frameworks, the Vulkan, the content pipeline. These all require effort and time. Although, yes, MonoGame is open source, so the project is free to end-to-end access. It's not free to build. It's an interesting point in the situation. But anyway, that's been most for today. I hope you enjoyed, and later on with the framework.